Hi, everybody. Welcome back to our second live session of this course, which is a basic course in number theory. Already some members are here waiting for us. So thank you, VK, for your greetings. ABCD and Nicholas would perhaps like to repeat their messages later. And thank you, Sridhar, for putting up this point. If there are any questions, please feel free to ask them. There are one or two questions which are there in the Excel sheet. And so, Nicholas, thank you. Good evening to you also from me and as well as my team. Very good to see you again here virtually. Before I go to the questions, I would like to see if there are any questions here. I think, now we are getting towards the business end of the course, meaning soon the assignment 10 will go live. Assignment 9 is already live and you are working on those things. So 10, 11, 12, and then we have the final exam. So not many weeks to go, less than a month perhaps. The exam may be slightly after a month, but the course will be over soon. So not many opportunities for us to discuss. Let's make good use of this opportunity. Okay. So let me start with this question which Nicholas has asked in the Google sheet that he has given. All right. So Nicholas has asked, can a negative definite quadratic form be reduced like the positive definite quadratic form? So, all right. So, what happens is that definite quadratic form is one, which will take values which are 0 or of one particular sign. So, it could be all positive values and 0 and no negative value, or it could be all negative values and 0 but no positive value. Correct. So that means whenever you plug in any value, suppose it's a binary quadratic form. These are the ones that we have been studying, right? Meaning these are forms in two variables. But later, of course, we are thinking about universal forms and so on. So the binary forms, which are in two variables, for which we are discussing the form being reduced and so on, are forms in two variables. So when you plug the values for A and B, then a negative definite form will always give the values which are non-positive. They can be 0 or they can be negative. If you multiply this whole form by -1, then you get a positive definite form, because suppose your form looks like minus x square minus 2xy minus y square. Or if we are thinking about AB, it can be minus a square minus 2ab minus b square. So this is minus of a plus b whole square. Now, squares are always positive or 0. Therefore, when you put a negative sign to that, you get a negative definite quadratic form. But if you put another negative sign to a negative definite quadratic form, meaning you multiply all coefficients by -1, then you get a positive definite quadratic form, and that positive definite quadratic form can be reduced, you can study, and so on. So can a negative definite quadratic form be reduced? That is something one can study, but actually there is no need to do that. The reason why do we study reduced forms? We would like to study the numbers represented by a given form. This is the basic question. So once we have a given binary quadratic form, we would look at the reduced form whose coefficients are, in the sense, the optimal coefficients. So once you have the optimal coefficients, we call the form to be reduced. Given a quadratic form which is positive definite, if we want to study the numbers represented by a quadratic form, these are the same numbers which are represented by the reduced form. And so therefore we study reduced forms. The need for reduced forms is not that, we thought that it would be nice to study this variant, and so we have introduced and studied. There is this possible aim in our mind that, we would like to study the values represented by quadratic form. So if you wanted to study values represented by a negative quadratic form, we are discussing Nicholas's question, then you multiply all the coefficients by -1, you will get a positive definite quadratic form. You take its reduced form. That reduced form and your positive definite form will represent the same values. The value set is same because these are equivalent. So you get values represented by the reduced form, and further you put a negative sign, because remember that we had obtained our positive definite form from the negative one by putting a minus sign. So once you do that, you will get the values represented by your negative definite quadratic form, and that will suffice. So while it may still be possible to think about what would be the reduced form corresponding to a negative definite form, it is not really necessary. Or what you could do is that you take its positive definite form, take the reduced form, and once again you multiply by -1. You will get something which is going to be equivalent to your form. This is answering Nicholas's question. Golfin NO has said very correctly that some assignment questions, the answers which were suggested by us are not correct. The options which were given to you, they were not correct. So that we will make a change to that soon. And once we make that change, the marks will be reflected in the assignments. So this will be done soon. Good evening, Pallavi. How are you? I hope everyone is fine. So maybe I could wait for 1 or 2 minutes and then go for the questions which are asked here. It's again a question asked by Nicholas, so maybe I could see if somebody else can give a. So Kaustubh Kamli has asked some question about assignment 9, week 9. He has asked about some largest values represented by a quadratic form, and he has said that there is one particular value which is not part of the given options. So what I suggest is that you take among the options, you take the largest possible which is represented by your form. You should do that. So Vaibhav Vishwakarma has asked, will there be partial marking in the final exam? Yes, there will be partial marking. So final exam, I am now not sure if I should wait or give away the secret right away. What should I do? Let me see if somebody agrees with Vaibhav and asks question about final exam. Nicholas, can we play this same eigenvalue and the same discriminant? Okay. Anybody for final exam? All right. Vaibhav has asked, so let me go ahead with the answer. So what will happen is that, in the previous live interaction session, I think I have already said that so Sridhar has already given answer. Yeah, let me elaborate further on the answer given by Sridhar. So what will happen is that there will be several steps in the question paper. So for instance, if I want you to compute reduced form for a particular given form, then I will ask some questions. I will ask whether A is less than B. We have for reduced form, we have some conditions on A, B, and C. So I will ask whether A is less than B. If yes, or if yes, then what is the matrix you will multiply by, or what is the transformation that you will use to get the form which is slightly reduced than the form that you have started, slightly lower form than the one you have started. Now is the A less than B, is the middle term, which perhaps that is B. So I should ask whether A is less than C and whether the middle term satisfies the correct inequality. So those will be the things. So there will be steps for all these. There will be marks for all these steps. And if you write all steps correct, then of course you will get full marks. And if you miss some of these steps, but some other steps are correct because this is machine graded. It can happen that you give the first answer incorrect, and then logically all your answers should be incorrect. But this is machine graded. So if you, by accident or by some clever trick, if you give further answers to be correct in the same question, if you correct yourself in the next steps and give the correct answers, you will get full marks for those steps. All right. So Nicholas has also, sir, I have one more question. Can you please explain whether equivalent has same eigenvalue and or same discriminant? So which one are we thinking about? Meaning, given a quadratic form, you are looking at the 2 by 2 matrix, which gives the quadratic form. Is that what we are thinking about? So, what happens is that when we take the quadratic form and apply the linear change, what happens is that the matrix changes by, so if B is the matrix, then B will change by A, B, A transpose. It doesn't become A, B, A inverse. If it were to become A, B, A inverse, then we would have that the matrix, let me think again about it. I think, do we make it A, B, A inverse or do we make it A, B, A transpose? At the moment, I'm a bit confused about it. I don't recall. So if it becomes A, B, A inverse, then the matrices are conjugate and therefore they should have everything same. Their eigenvalues will be the same And by discriminant, I suppose that you mean the determinant, or the discriminant of the quadratic form certainly will not change. If the quadratic forms are equivalent, the discriminant will not change, and I guess the eigenvalues also don't change. I think what we do is that we do A, B, A inverse. It's not A, B, A transpose, because A, B, A transpose may have some effect which is not irreversible, whereas our equivalence is reversible. So it is indeed A, B, A inverse, and so the eigenvalues are same and the discriminant is same. Good. So Sridhar has already answered from the NPTEL team. Nicholas said, I got both the questions in assignment wrong in assignment 8, but I got the rest correct. So if your two answers are incorrect, then, for assignment, I think we have a different policy. And that is something which is announced right at the top of the assignment, saying that, you have to answer all, you have to choose all the correct options and no incorrect options, only the correct options. Then you get the full marks. So if that has happened, you should get full marks. And if you haven't got, then you should point it out on the discussion forum. So let me also take this opportunity to, inform everybody again that there is a forum which is solely for discussing the various doubts that you can have regarding this course. What is happening is that I have prepared some videos maybe 2 years back, and I have shared those videos with you through NPTEL. And then there are assignments. So there is no personal touch. Also, these live sessions cannot be held regularly, meaning, we have it 3 times a course, or say like once a month. But we cannot have it every week or so, because, obviously you will be busy, I'll be busy, and so on. So what we have done is that there is a forum which is called for Q&A. And when you go to the course page, on top there are various links. So there is one link called Q&A. If you click on that, then you will be taken to Google group for your Gmail account. Or if you have any other address, then I suppose you will still be taken to Google group. And from those 2 Google groups, there will be 2 of them. There will be one for announcements and there will be one for discussion. If you have registered for more than 1 courses, then you will have doubly those many groups there. If you have registered for 5 courses, you should see 10 Google groups. Announcement for each of those courses and discussion for each of those courses. So if you go to the discussion forum, you can see all the things which have been discussed previously. People routinely ask questions. I am very happy that all the learners have been asking questions without any prohibition, meaning there is no hesitation that you should have. Of course, meaning, you are spending, I would have said that you are giving your money for this, learning this course, but more than that, you are giving your time. Time is invaluable. You are giving your time, so you have a right to learn everything. If there is anything wrong, please feel free to, announce there publicly. And if it is wrong, I will admit. Meaning, nobody is perfect. So if there is something wrong, I will of course admit, and then we will have some way to retrace that. Okay. So go to that Q&A session group, and there you can ask these questions. So Nicholas, if you have given some correct answers, but they have not been given correct, then please raise this question there. I think you are already quite active. So I don't have to tell this to you, but with, taking the opportunity of your question, I am informing everybody. You are welcome, Vaibhav. Kaustup Kamli is, can we get access to the previous year's question paper for reference? I think that is not possible. Unless you know somebody who is there already in the previous year's batch and so on, perhaps this is not done. This is not the practice. What has happened is that, after all, this exam is taken by several 100 or 1,000. So if you see our course is, there are thousands of students who have registered, and a few hundred students have registered for the examination. So making this thing available to everybody is not a good idea. I think we are advised by NPTEL and also by some other colleagues that let's not make the question paper available, because, after all, we are humans and we don't have infinitely many ideas. The ideas that we have are only finitely many. So it would not be fair to, tell you what type of questions are asked, other than the fact that, everything that you have learned, only that will be used for solving those questions. So Golfin has again reminded me that partially marks are not credited, but this is indeed the case. If you have a question and in that question if there are 3 correct answers, you have to choose all 3 and no incorrect answer. You should choose all correct answers and only correct answers among the options given in the question, below the question. Only then you get full marks. So for assignment, partial marks are not there. Nicholas says that then I feel that the answers are wrong as marked in the assignment as per what you are saying. Good, Nicholas, what you feel, please feel free to share this on the question and answer session. You know, what will happen is that when I read those emails, I will have access to the question paper, I will have access to the answers that I have prepared, so I can quickly verify. Here at the moment, the only thing I have is a water glass, so I cannot really, go and check the questions, the answers, and so on. Please feel free to raise this on Q&A, then it will be available also to everybody. So if not for you alone, for everyone, you should raise this question on the Q&A forum. Good, you have suggested something, so please raise it there. About something about the forms, yeah. Okay, Pallavi has asked, if f is equivalent to g, then the discriminant of f and g are equal. This is correct. But if discriminant of the forms are same, then f is equivalent to g or not. So typically, in mathematics or, in general, this would be a great thing if this were really to be true. Meaning it would mean that your form, which is represented by three numbers, meaning there is a square plus bxy plus c, ax square plus bxy plus cy square. You need three numbers to represent a form. And if it were to be determined by only the discriminant, which is a single number, then it would be a very, very, very remarkable result. That is not true. And in fact, what we have also said is that given any discriminant, we have listed out what are the possible discriminants. There is, given a discriminant, there is something called class number of the discriminant. So given a discriminant, there is a field extension of rational numbers, which is associated to that discriminant. And then there is a finite group associated to that field extension. The cardinality of that finite group is what is called the class number of the discriminant. So it will tell you how many different forms are there of the given discriminant. And this number is not always one. For some forms, it will be one. For some discriminants, this number will be one, which will mean that any two forms of the given discriminant are equivalent. But there are some numbers for which the forms, there may be two different forms which are not equivalent. There will be inequivalent forms but have the same discriminant. That can happen, which is what makes it interesting, right? Okay, I believe there are a sizable number of students here. So there is a question asked by Nicholas in the proposed in the submitted sheet, which I would like to discuss now. So this question says, meaning once you are given a natural number n, then we want to see whether there are primitive roots modulo the given number. Okay, this is what we would like to study. And he said, is there any simpler method, trick, or shortcut that you know when attempting to calculate if a number is a primitive root mod n? When n is a larger prime number, and of course, because it's a large prime number, and so it's not a power of a smaller prime. So what he's asking for is that you have a large number n, which is not a power of a small prime. So let me spend a minute or two in discussing the case when your n is a power of a small prime. What happens is that if you are looking at p square or p cube or anything, higher power of p, not equal to p power 1, but the higher ones. And if you want to check whether some number is a primitive root modulo this p power I, then it will have to be a primitive root modulo p. Okay, this is a fact. Therefore, to check whether a given number is a primitive root modulo p power I, suppose you are given, let's say, what would be a good 343, which is cube of 7, right? So if you are given a number and you want to check whether it's a primitive root modulo 343, what you should do is that you should check whether the residue class of that number modulo 7 is a primitive root modulo 7. If it is not a primitive root modulo 7, then it cannot be a primitive root modulo 343. Okay, this is for powers of small primes. Also, once you have it to be a primitive root modulo p, is it a primitive root modulo p square? This is the thing we have to check. If it is a primitive root modulo p square, it is going to be a primitive root modulo all higher powers. So checking for smaller powers of primes is enough to check the quantity for higher powers of prime. Okay, that is why Nicholas has asked this question very cleverly, that the given prime, given number is not a power of a small prime. Okay, so now if the number is a prime number, then you know that there will be primitive roots. If the number is not a prime, but it's a large number, you should calculate its Euler-Phi function. Once you calculate the Euler-Phi function, or once you compute its prime power decomposition, this will be needed when you want to compute the Euler-Phi function, right? So if you decompose it into prime powers, you will immediately be able to figure out whether the number has a primitive root or not. We know what are the numbers which have primitive roots, right? They will have to be powers of odd primes or 2 times powers of odd primes. These are the only numbers which will have primitive roots. If your number is not one of them, then you don't start thinking about primitive root, because that number will not have a primitive root. Now, if your number happens to be either a prime or a prime power of an odd prime, or it's 2 times an odd prime power, but the prime itself might be very big, then what do you do? So this is a very standard trick. I think, if you look for any book on computational mathematics, or, some website where there would be, which could be devoted to computational mathematics, or there could be some articles which are expository articles. So you will see this following method, which is one very basic method. You start, so his question also says that given number is a primitive root or not. That's what he wants to check. So we want to start with a given number g, and we want to check modulo n whether g power correct number gives you 1. The order of the element g has to be the full order of that group of units modulo n. Now the group of units modulo n has order phi n, the Euler-Phi function, right? So your g power phi n should be 1. When you raise g to the order phi n, you should get 1. And for no smaller power should you get 1. This is what we have to find out. So condition 1 is that g power phi n equal to 1. That is not needed to be checked, because the group has order phi n. Every element power phi n will have order 1, will have result 1. So that is something you don't have to check. That is given automatically. Then what you do is that, as you have computed the prime power factorization of n, you compute the prime power factorization for phi n. Correct? So there will be, say, q1, q2, qr. These are the primes, distinct primes, which divide phi n. You compute g power phi n upon q1. Okay? So phi n upon q1, if you compute this power of g, check whether you get answer to be 1. If you don't get answer to be 1, go to the next prime. Phi n upon q2. Raise g to this power and check whether you get 1. Do this for all prime factors of phi n. Typically, if your n is very large, phi n will also be reasonably large, and then hopefully the prime factors that you have for phi n will also be large. And therefore, this ratio will be small. And so you will be able to compute easily whether g power phi n upon qi, whether that power of g is 1 or not. And there is one very nice way to compute these higher powers also. What you should do is that, given a number, compute its square. Once you have that number, reduce it modulo n, compute the square again. So you need to compute the first power, which is the number itself, second power, fourth power, 8th power, 16th power, and so on. And now if you want to compute one particular power, suppose you want to compute the 7th power. 7 is 4 plus 2 plus 1. Because every number can be represented in binary expansion. So 7 is 4 plus 2 plus 1. So g power 7 is g power 4 into g square into g. That will tell you what is the value of g power 7. So this is the way by which you can compute various of these numbers, g power phi n upon qi. And once you have the answer equal to 1, then it's not a quadratic, it's not a primitive root modulo n. But if the number is different from 1 for all of them, then it is a primitive root. Because we already know that for phi n, for Euler phi function, as that as the power, g to that power is 1. And for no prime factor qi of phi n, g power phi n upon qi is 1. Then it cannot be 1 for any divisor of phi n. And hence g power phi n equal to 1 is the only possibility for the power of g to be 1. In that case, it's a primitive root. Good. Golfin and sir, last assignment, A value less than or equal to C equal to A minus BC. Yeah, so Golfin meaning the point is that I cannot explain the explicit assignment questions in this session. This session is not supposed to be to discuss various assignments. If you want to know about modalities, or if you want to know some concepts, or if you want to know some such methods and so on, then we could try to discuss that. I cannot discuss any particular question here. So Himanshi has asked again, can I get previous year's papers? So no, I think we don't have that policy of sharing previous year's papers. Kapil Kumar has asked a question. In assignment 4 of question 6, answer should be CF, but given answer is CE. And for Q8, answer should be ABF, but given answer is ABE. When will this mistake is getting rectified, get marks for these? So this is what happens when you don't join from the beginning. This question already came up, and the question is answered saying that it will soon be done. It is not yet done. So don't worry if you have not got the marks yet, because it is not yet done. It will be done, and we will all inform you about it. So there is the announcement list. I think those emails are sent to you, so you will get to know about that. Okay, so I think I have answered all the questions which were asked in the Excel sheet. If there are any other questions, please ask so that I can talk more. You are welcome, Kapil. So I think what NPTEL people do is that if we don't speak for 2 minutes, then they close the session. This is the secret. So you should keep asking questions so that I can keep talking. Golfin, Nicholas, Pallavi, Himanshi, any other questions? Kapil, would you want to know anything further? Anything else? I think there was a question asked in the question forum. Can you please about HD? So HD is that form, HD is the class number. HD for any given D, which can be a discriminant, HD is the number of inequivalent reduced forms of that discriminant. This is what HD is. So Golfin has pointed out that in public exams, calculators are, so there, there is something which goes below this, so I cannot see the question fully. Okay, so he wants to know whether the calculators are permitted. The calculators are not permitted, but what happens is that there are inbuilt calculators in the system. So when we have the inbuilt calculators, then you can use those calculators. But you should also remember that, meaning the power of those calculators is not very big. So what you should also do is that be judicious about how you perform various operations with that given calculator. There will be calculators in the system itself. You will not be allowed to take calculator from your home. There are many scientific calculators, and there have been many cases of misuse of given facility. So what we have decided is that we will give you calculators in the system. You can use those calculators and solve all the questions using them. Those will be scientific calculators. Although we will not be requiring, you can compute sine, cos, and so on also on that. So if there are any further questions, we can continue. Yeah, indeed. So Kaustubh has asked this question, which is a very regular question when we study various of these points about reciprocity laws. Meaning proofs of reciprocity law is not, they are not easy. This is something that we should just accept. Meaning, it's like while playing like cricket, somebody may be there who will try very hard to learn cricket and so on. But ultimately, that person cannot become a Sachin Tendulkar. So there is one Sachin Tendulkar, there is one Virat Kohli, there is one Rohit Sharma, and then there are people like us. So there are a few things which are difficult. We have to acknowledge that yes, these are difficult. We can learn them using some methods, meaning we have books, we have various articles which are available on the web. We can try to learn them. In fact, there are many proofs of quadratic reciprocity laws. And in fact, the third law that you are talking about, that is especially the most important quadratic reciprocity law, which tells you about P by Q into Q by P is -1 to the power P minus 1 by 2 Q minus 1 by 2. That is the most difficult law to prove. And in fact, when Gauss proved it, he was very happy with that. He was very happy that he had a proof of it, and he was not happy with one proof. Gauss himself gave several proofs. And there are many proofs of this result which are available on mathematical literature. There is in fact a book called Proofs of Quadratic Reciprocity Law. One book is written where all the proofs are recounted, they are given. So there are many proofs, and indeed, when the proofs are in those many numbers, then we can understand that the theorem must be important, and people are trying to understand the proof, giving different methods and so on to see what is really going on. There are some mathematicians who understand what is going on, but it's not possible for everyone to understand. And so we should acknowledge that there are a few things which are difficult. And if we understand the statement of the theorem and if we can use it while doing mathematical calculations, perhaps that is something that we will be happy with for the moment. But we could try to, meditate upon that, think about it. This is what will happen. Sometimes it will not immediately come to our notice, but maybe at a later time, or if you continue doing mathematics, at a later time, you will suddenly realize that, oh, this is what it is. Sometimes it may also be something that, you learn some higher mathematics, and in that light of higher mathematics, where you learn about other reciprocity laws. This is only a quadratic reciprocity law. There is a cubic reciprocity law. There are abelian reciprocity laws, which are there for all n. And then there are non-abelian reciprocity laws. So in the light of some reciprocity laws, you may think that, okay, this is now a simpler thing. And now you understand the motivation behind it, but that will take quite some time. But yeah, meaning quadratic reciprocity laws are part of very beautiful mathematics. And I was very happy, when I decided what are the things that I could do for this course and how the proofs went and so on. So I think one person called Dr. Isha Garg in the our question and answers Google group, she had asked question about meaning what is the way we could think about the final exam and so on, or can I give some idea about it? So we could in fact have some idea about it. So Kaustubh has asked a very difficult question. So, how will the final exam happen? So, what happens is that if you look at our course very carefully, the things which are developed in the first parts of the course are the ones which are used in the later part. For instance, we have developed the notion of modular equivalence, modular, the residue classes and so on, numbers modulo n. Then we use them to solve the, the simultaneous congruences. So simultaneous congruences are solved because we have understood the modular arithmetic very well. And after that, we then thought about quadratic reciprocity law. And while studying quadratic reciprocity law, you would see that modular congruences show up. If we want to see whether phi modulo p, phi sub p is that one, what are the primes for which phi is a square? Now, p, when is p a square modulo 5? That is easy to see because modulo 5, the squares are 1 and 4. These are the only two squares. So, if you have a prime which is congruent to 1 mod 5 and a prime which is congruent to 4 modulo 5. So, 11. 11 is a number which is a square modulo 5. And similarly, if you were looking at 19, 19 is a square modulo 5. So, these are the numbers which you can quickly rattle off. Similarly, if you were thinking about phi upon p, when is phi upon p a prime? Then you will use the third quadratic reciprocity law to invert the positions of p and phi. To study phi upon p, using the third law, it is enough to study p upon phi. If you were looking at 3 by p, it would be enough to study p by 3. And then you will get some conditions using the modular arithmetic. So modular arithmetic is now being used while solving the quadratic reciprocity law or while answering the question about what are the particular numbers for which a particular prime is a square. So all the things which are developed in the initial parts of the course are going to be used in the later part of the course. So, in the exam, it is likely that there will be no question to tell you, it cannot, perhaps there will be no question saying that if n is 3 modulo 4, what is phi n modulo 4? That's a very easy question, in something like anybody who is in the first standard or second standard, and if you explain the person about clocks and so on, that person will be able to answer this. These are not the questions that will be asked. But modular arithmetic will be used. It's not that we will simply say that whatever we do now on is independent of modular arithmetic. That is not what it is. Modular arithmetic will be used to study the higher things. There are even further things that you are going to study, right? Meaning right now you may be studying the continued fraction and expansion and so on. There are some more interesting things which will come after this. So those things will use some of the material that we have developed in the previous weeks. So ideally, I don't know if that is how it will finally be. Ideally, the questions will be where a sizable number of the material developed in the course is used. And mostly it will be computational. Once again, I am, giving away this secret that it will be a computational exam in the sense that you will have to do some computations to get the final answer. And there will be various steps required to get this answer. And for each step, there will be marks. Kaustubh has asked this question, which I said is a very difficult question. May I know your favorite mathematician if I can ask this question? So, this can change. You may come after 10 years saying that, sir, you had said that was your favorite mathematician. Now you are saying this is your favorite mathematician. But anyway, so there is a French mathematician by name Jean-Pierre Serre. His name is Jean is Jean. Pierre is Pierre. Jean-Pierre Serre, Serre. He is a mathematician of the highest class. Among the alive mathematicians, he is 90 plus, but he is still active. So